Hey guys, what is up? Today we will learn about atomic structure and main group element. Before I jump into my topic, let me introduce myself first. I am Ivan Said and I am the chemistry instructor at Solving Hero Academy. Basically, we work on CSCA exam. We teach the student and help the student. So if you have any question or query about the exam, you can freely inbox us or you can freely join us to our WhatsApp group. In the comment section, the link will be provided. So by the link, you can easily join on our WhatsApp group. So let's jump into the topic. Here is our first topic: the anatomy of an atom. So we'll learn about atom today. The first topic. So here, at first, there is a scientist called Rutherford. Rutherford gave an atomic model. He gave an atomic model. If you assume this as sun and these are planets, just assume that these are planets. We take this as another planet. Here what is happening? The planets are rotating around the sun. These planets are rotating around the sun, right? And here is the sun is the center point. So as like that, as the planets are rotating around the sun, in the same way, in atom the center point is called nucleus and the electrons are rotating around the nucleus. What did I say? In the same way, if we take this as assume this as nucleus, so by around the nucleus the electrons are rotating. So we can easily compare the sun to this nucleus, right? And these planets with these electrons. As the planets are rotating around the sun, the electrons are rotating around the nucleus. Here if you take another electron, this electron are rotating around the nucleus. So this both are same. I mean not same, but we can compare this. So this is called solar system model. What do we call? Solar system model. So in a solar system model, the planets are rotating around the sun. In the same way, the electrons are rotating around the nucleus. So we will postmortem this nucleus. How? So let's take it as nucleus, and here electrons are rotating. So here electrons are rotating. So what does lies actually in the nucleus? In nucleus, proton exists. What did I just say? In nucleus, actually, proton exists. These protons are positive charge. And these electrons are negative charge. So we call this nucleus as positive. What do we call this nucleus? This nucleus is positive charge, and these electrons are negative charge. Clear? So here is a fact that proton equal always electron number. If you take two proton, there will be two electrons are rotating. If you take one proton, there will be one electron rotating the nucleus. If you take three proton, what did I say? So that means three electrons are rotating around the nucleus. Am I clear? So proton number equal always electron number. That means if you have three positive charges in the nucleus, you will get three negative charges in the electronic shell. Achha, here is one thing that what does this called? where electrons are rotating. Electrons are rotating in these places, right? In these places. What does this places called? This is called electronic shell. What do you call it? Electronic shell. In this electronic shell have a minimum energy, and the electron have that energy, so that the electron can easily are rotating around the nucleus. What did I say? These are called electronic shell. These are called electronic shell. This shell has some energy. If an electron have this much energy, then an electron can rotate in this shell. Am I clear? So you have just to remind that or memorize that these are called electronic shell. So here is the fact that, let me tell you, at first shell, what did I say? At first shell only 2 electron can exist. At second shell 8 electron can exist. At third shell 18 electron can exist. So at first shell 2 electron can exist, second shell 8 electron, and in third shell 18 electron. So let me just write first shell. How much electron can stay here? 2 electron. In second shell 8 electron, and in third shell 18 electron. Am I clear? So here is the postmortem of an atom. So what did we just learn? So we learned that Rutherford solar system atom model. What does this model tell us? This model tells us that as the planets are rotating around the sun, in the same way the electrons are rotating around the nucleus. This nucleus have proton, these are positive charges, and the electrons are rotating around the nucleus, which are negative charges. Am I clear? And the electrons are rotating in this shell. These shells are called electronic shell. And how much electron can stay in this shell? At first shell 2 electron can stay, at second shell 8 electron can stay, and at third shell 18 electron can stay. So here is the postmortem of an atom, I mean anatomy of an atom. So hope you have already understand what have I explained just. So let's just take a minute. So sorry. So what we have just learned, anatomy of an atom. So just let's have a look on the slide. What does the slide say? At first, let me take a pen. At first, a structure and configuration. So focus, you will learn isotope, proton, neutrons, electron, and electron arrangement. So the first slide, the atom. We have already explained you how does the atom actually looks like. Think of it like a solar system. I have already previously said that about the Rutherford, how the Rutherford atomic model. Just right, we have learned that the sun is the nucleus. Here we said that, right, the sun, as the sun stay in the center and the planets are rotating, in the same way the nucleus and the electrons are rotating, right? So the sun is the nucleus holding positive and protons neutral neutrons. The planets are the electrons. Here, as the planets are rotating around the sun, in the same way the electrons are rotating around the nucleus. So orbiting in the specific path called shell. Shell, that means electronic shell. What did we say? Electronic shell. So clear? Okay. Okay, so let's jump into the next topic. What is isotope? We will learn what is isotope. Before I teach you isotope, let me have a look in this model. What is called proton, the mental model. You don't have to focus on the mental model or apartment building analogy. You just have to memorize the name. Proton. We have already said what is proton. In the nucleus. there are positive charge called proton. Neutrons, we will learn about neutrons after few minutes. Electronic shell, what are electronic shell? In the around the nucleus, the electrons are rotating. The electrons are rotating in this shell, and these shells are called electronic shell. And subshell, what is subshell? S, P, D, F. We already know that 1s2, 2s2, 2p6, 2s2, 2p6, these are called subshell. We will discuss about this later, but at first you have to just focus on proton and electronic shell. So clear? So the question about this, before I jump into another topic, let me first explain what is isotope. So now we will learn what is isotope. So let's jump into the topic. So what is isotope? Before I explain isotope, you have to learn how I represent an atom. Atom represent. A atom is represented by in this way. If we assume X as an atom, in the head of the X, the atomic mass is taken, and in the foot or under the X, this is called Z. This means if we assume that as an atom, what did we just say? Sorry. So if we assume that as an atom, in the head of the X, we write atomic mass, and under the X we write the atomic number. This is how we represent an atom. In an atom, so in the head, atomic mass is being written, and in the foot or under the X, atomic number is being written. For example, if we take carbon, the atomic mass of carbon mass equal, we know that 12. So 12 is written on the head, and atomic number is 6. So it is written in the under so it is written under the atom under the symbol C. So this is how represent an atom. Am I clear? How do we represent? If we take oxygen, what is the mass of the oxygen? The mass is the mass is 16, and the atomic number is 8. So how does we read that? So if we assume this as oxygen, the mass is 16, which will be written on the top, and atomic number 8, which will be written on the under the symbol 8. This is how we represent an atom. Am I clear? Here is the fact that must remember that atomic number. What is the atomic number? Atomic number equal proton number. Actually, if a atom have 2 proton, that means it's 2 proton, right? 2 proton, that means it have atomic number 2. What did I say? So 2 protons, that means atomic number equal 2. Am I clear? So if an atom has 3 proton, each atomic number will be 3. Clear? That means this carbon's atomic number is 6. That means it has 6 proton. As well as we have already said that, so we can reach to a conclusion that what conclusion? atomic number equal proton number actually. Am I clear? And we have previously already said that proton number equal electron number. So we can say that atomic number equal proton number and equal electron number. Am I clear? So this is how we represent an atom. So if we take let us assume chlorine, we know that what is the mass? The mass is the 35.5 and atomic number equals 17. So 17 is written under the chlorine symbol and the mass is written on the head. Am I clear? 35.5. Am I clear? This is how we represent an atom. It's very simple. So now we have to learn, we will learn about isotope. What did I just say? Now we will learn isotope. What is an isotope? If two atoms have same number of protons, these are called isotope. What did I just say? If two atoms have same number of protons, it will be called isotope. Let us assume carbon, 12 carbon 6 and 13 carbon 6. So we have already represent, right? So here is the atomic mass. So its atomic mass is 12, its atomic mass is 13. So and we know that atomic number is written under the symbol here, atomic number. So its atomic number is 6, its atomic number is 6, and we also know that atomic number equal proton number. So this atomic number 6, that means these have 6 proton, these have 6 proton. Am I right? So it's these 12 and 13 both are atomic mass, and 6 these are atomic number, that means proton number. So this 12 carbon 6 and 13 carbon, these two carbon have same number of proton, right? This carbon have 6 proton number and this carbon have proton number 6, both have same number of proton number. So this will be called isotope. This will be called isotope. Am I clear? Cause what is isotope? What is isotope? Just let me write down. If two atom has same number of proton number. Am I clear? If two atom has same number of proton number, this will be called isotope. So this 12 carbon 6, 13 carbon 6, these two have same atomic number, but these two atom have different atomic mass. But see, these have 6 proton number and this carbon has 6 proton number. So this will be isotope. We can also say that hydrogen. This hydrogen's atomic mass is 1 and proton number 1. This hydrogen have same atomic number, is atomic number 1, I mean proton number 1, but its atomic mass is 2. So if you compare these two atom, this hydrogen has 1 proton, this hydrogen has 1 proton, right? So as these two atom have same number of proton, this will be called isotope. Am I clear? This is very simple. So here we will learn another topic called, see, always keeps in mind that let me take the here is the fact that mass equal proton number plus neutron number, proton number plus mass equal proton and neutron number. So we represent mass as A and proton number as Z and neutron number as N. So we can easily write the formula as like mass equal Z plus N, mass A equal Z plus N. So by this formula, what did I just write? A equal to Z plus N. By this formula, where A equal mass, where Z equal proton number or atomic number, where N equal neutron number. Am I clear? So we can easily, by this formula, we can easily calculate the neutron number of an atom. Am I clear? By this formula, we can easily calculate the neutron number of an atom. For example, if we take 12 carbon 6, here this is the Z or proton number, this is the atomic number A. So what will be the neutron number? From this formula we already know that A equals Z plus N. So I mean Z equal here proton number and A equal mass. We represent mass as A, we represent proton number as Z. So here how much neutron this atom has? How much neutron? So we can easily calculate neutron equal A minus Z. So that means if you if you minus Z from A, you will get the neutron number. Am I clear? How you will get the neutron number? If you minus the proton number or Z from the atomic mass, you will get the neutron number, N equal A minus Z. So here what is the A? See, A is 12 and what is the value of Z? The value of Z is 6. So 12 minus 6 equal 6. So this carbon have neutron number 6. Am I clear? How much neutron this have? Neutron number 6. Am I clear? So what have we just learned? We at first learn how we represent an atom. If we take X as an atom, the atomic mass is being written on the top of the symbol and the atomic number or the proton number is written on the here. So let me just take another pen. Wait. So what we just learned? Atomic represents. So atomic mass is taken on the top and atomic number is taken on the under the symbol. So if we take this have mass 12 and atomic number 6. So here the mass is written on the top, the atomic number is written under the symbol. Am I clear? So as same if this chlorine have mass 35.5, so this number is written on the top and this atomic number is written in the under the symbol. Another fact that we have already said that atomic number equal proton number. That means atomic number, actually proton number is called atomic number, and we have already said that electron number equal proton number. So atomic number, proton number, electron number, these all are same things. So then we have learned what is isotope. What is isotope? If two atoms have same number of protons, it is called isotope. This carbon have proton number 6 and this carbon has proton number 6. If you see carefully, this carbon have mass of 13 gram and this carbon mass of 12 gram, but this has 6 proton, this carbon has 6 proton. So these are called isotope due to cause these two atom have same number of proton but different mass. So as these two atom have same number of proton, so this is called isotope. Am I clear? So we can take this hydrogen as example. This hydrogen have one proton, this hydrogen have one proton. These two hydrogen have same number of protons but different atomic mass. So this is called isotope. Am I clear? So and we have to learn a formula that mass equal proton number and neutron number. What have I said? The mass of an atom equal the proton number plus neutron number. The mass is represented by A, the proton is represented by Z or atomic number. So and the neutron number N. So A equal, we can learn that Z plus N. Am I clear? So A equal Z plus N. So by using this formula we can easily calculate the neutron number of an atom. Am I clear? So this carbon has 12 mass here and this carbon has 6 proton. Clear? So we know that atomic mass equal Z plus N. Here how so the neutron number equal A minus Z. So here the A means atomic mass. So atomic mass is 12 and Z proton number is 6. So 12 minus 6, these have 6 neutron. Am I clear? So just for example, we can take another molecule. If we take oxygen, so no oxygen, not oxygen. Let me take hydrogen. So this hydrogen and this hydrogen, we know that let me take the mass is written on the top. So if this hydrogen have mass of 2 and this hydrogen have mass of 3, clear? This hydrogen's atomic number is 1 and this hydrogen's atomic number is also 1. So the neutron number equal, we know that neutron equal A minus Z. Clear? So this hydrogen's atom mass equal 2 and proton number 1. So if we minus the proton number from mass, we will get neutron number 1. And here this hydrogen have neutron number, this mass have 3 and this have 1 proton, 3 minus 1 equal 2. So this hydrogen have neutron, 1 neutron and this hydrogen have 2 neutron. That means these are isotope, right? These are isotope. So we can reach why these are isotope. It have 1 and it have 1 proton. If two atoms have same number of proton, these are called isotope, right? So in isotope this proton number are same, but the mass number, you see the mass number are different. This hydrogen's mass is 2, this hydrogen has a mass of 3 and this hydrogen has a mass of 1, neutron number 1 and this hydrogen's neutron number is 2. Am I clear? So we can reach a conclusion. What conclusion? In isotope, in an isotope the proton number are always same, but if you see this hydrogen has mass 2, this hydrogen 3, that means mass are different. So two isotope have same number of proton but different number of mass. So proton number same but different mass. Also if you see that this neutron have number 1, this neutron have number 2, that means only this number are same, that I mean proton are same, only proton are same, 1 1, but see mass 2, mass 3, this hydrogen's neutron 1, this hydrogen's neutron is 2, that means neutrons number are also different, mass number are also different. Am I clear? So in an isotope proton number are same but they have different mass and different neutron number. Am I clear about this topic? So we have learned about the atomic represent, what isotope, and we have also learned that isotope have same number of proton but different number of mass and different number of neutron. Am I clear about this? So this was our first topic about. So we will learn some previous question that was given in the previous first CSCA exam, and now we will solve the first question. We will solve the previous question. So let's jump into the first question. Here is a question that, let me just give me 30 seconds. So here is our first question. What is the first question about this topic? Which of the following statement about 13 carbon is incorrect? That means there are 4 statements, A, B, C and D. So the question is about what is the statement, including these 4 statements, which one is incorrect? So let's see the statement. What are the statement? 13 carbon, 12 carbon. Look carefully. You have to find out the incorrect one. Am I clear? So carefully find out the incorrect statement. If this statement becomes true, it will be not the answer. The answer will be which one is incorrect. So this 12 carbon, 13 carbon have same number of electrons. So let's look. 13 carbon, 12 carbon. We know that it has 6 proton. That means, see what I have said, that if an atom, why this 12 and this 13, what are these? I have already said that in my lecture. The atomic mass is written on the top. That means this 12 and this 13 are the mass. This 13 and this 12 and 13 are the mass. Am I clear? So this 13 and these 12 are the mass. Am I clear? So these are mass, but these have proton number 6. This carbon also have proton number of 6. Am I clear? So what have I said that just so this 13 carbon and this 12 carbon both have proton number 6. Am I clear? Cause atomic number, this carbon and this carbon, what is the atomic number? We know that atomic number equal 6. Am I right? So the atomic number is written under the symbol C. So these have a mass 13, these have mass 12. Am I clear? This carbon's mass is 12, this carbon mass is 13. So, and this carbon have 6 proton, this carbon have 6 proton. 6 proton mean 6 electron, this 6 proton means 6 electron, cause we have already said that proton number equal electron number. Am I clear? So if this carbon has 6 and this carbon have 6 proton, that means it has 6 electron. Am I clear? So this 13 carbon, if this 13 carbon has a mass of 13 and this carbon has a mass of 12, but so these have same number of proton, so same number of electron. So this statement is true. Am I right? Cause these two carbon have same number of proton, that means same number of electron, so the statement is true. Am I right? But you have to find out the incorrect one. You have to find out the incorrect one. Look at this option, 13 carbon, 12 carbon. So this carbon's atomic mass is 13, this carbon atomic mass is 12. These have same number of protons. Yes, these have same number of protons, cause see 12 sorry, let me just yeah, so sorry, so 13 carbon, 12 carbon, 13 carbon, sorry, I'm taking sometimes. So 13 carbon, 12 carbon, see these have the same number of protons. We have already discussed that it has atomic number 6, it has atomic number 6, that means these two have same number of proton, 6, 6, right? So these have same number of electrons, this isotope have same number of protons, so this statement is also true. Am I right? Look at, you have to find out the incorrect one. These are correct, this is correct, this is correct too. You have to find out the incorrect one. So 13 carbon, 12 carbon have the same number of neutrons. See, we have already shown you how to neutron number. See how we calculate the neutron number. If we minus the atomic number from the atomic mass, you will get neutron number. And this 12 carbon 6 has mass 12 and proton number or electron number 6, so neutron equal atomic mass minus atomic number 12 minus 6. Am I clear? We have already discussed how we have calculate the neutron number. So in the same process, calculate the neutron number. See, 13 carbon, 12 carbon, so neutron number equal A minus Z. Here A is 13 minus Z 6, that means 7, and this have neutron number equal 13 minus sorry, so 13 minus 12 12 minus 6, that means 6. So these have 7 neutron number, these have 6 neutron number. So these have neutron number of 7 and these have neutron number of 6. So this is the wrong, this is wrong. The question have already mentioned that which is the incorrect. So see, 13 carbon, 20 carbon have different number of neutrons, right? It have 7, 6, but in the option they have said that they have same number of neutrons. Will it be the answer? So see, you have to find out the incorrect one, and this is incorrect because these have different number, but here they mentioned that they have same number, but we know that they have different number of neutrons. So will it be the answer? No. So actually this is the incorrect one, and said that 12 carbon is an isotope of 13 carbon is an isotope of 12. Yes, 13 carbon and 12 carbon, these are isotope because it have 6 proton, it has 6 proton, and if the proton numbers are same, these are isotopes. So the incorrect one is this one. Am I clear? So the incorrect one is this one. So this is our answer. Am I clear? Because you have to find out the incorrect one, and this is the incorrect one because these 13 carbon and 12 carbon have different number of neutrons, but here given they have same number of protons. So this is the incorrect, that means this is the answer. Am I clear? So let's jump into the next question. The question asked, which of the following represent the electron configuration diagram of an argon? electron configuration diagram of an argon. So before I teach you about the diagram, see, we have already discussed that at first shell 2 electron, at second shell there are 8 electron, and the rest electrons will be in the third shell. Am I clear? So at second shell 8 electron, and in the upper shell, the outermost shell, here the rest electrons will be added. Am I clear? So 2, 8 and 18 electron. So argon, you have to represent the electron configuration diagram of argon atom. That means how will you represent the argon atom? We know that argon atom has an electron number 8, atomic number 8, right? So how we represent? At first shell 2 electron, at second shell 8 electron. See, at second shell 8 electron, so 2 plus 8, 10. So argon have 18, right? 2, 8, 10. So the rest, rest electrons will in the upper shell. So argon have in the first shell it have 2 electron, in the second shell it have 2 electron, and in the outermost shell it have 8 electrons. So 2, 8, 8, it have 18 electrons. Sorry. So it have 18 electrons. Am I clear? So argon, that means argon 18. So at first shell it has 2 electron, at second shell it has 8 electron, and as third shell it has 8 electrons. So the electron configuration diagram is 2, 8, 8. So see, and here is a fact that if the argon have 2 electron, then 8, and then 8 electron, right? So it has electrons equal 18. We have already know that in an atom the electrons number and the proton numbers are same. So it has proton number equal 18, because we know that if atom has an 18 electron, it will have 18 proton. Am I clear? So that means the proton will be stay in the nucleus, right? Here 18 proton will be stay. So 18 proton where stay, we already know that in nucleus the protons are stay. So as the electrons number and proton number are same, so if it has 18 electron, it has 18 proton too, and this 18 proton, nucleus, will stay in the nucleus. This proton will be stay in the nucleus. So this argon's diagram, in the nucleus it have plus 18 proton, and here minus 18 electron. Am I clear? So see, at first option they have gave us nucleus 9. See, argon has 18 nucleus. In B plus 10, 2, 8. This is not answer. But see, at the option C, these have nucleus 18. See, it has 18 proton. That means it has 18 plus charge or 18 proton in the nucleus. So this is the answer. And the shell are 2, 8, 8. See, at the option nucleus is 17. So this is not the answer, because we know that these nucleus have 18 plus charge, but it have plus 17, it has plus 10, it has plus 9. So the C number is the final answer. Am I clear? So this is the configuration of argon. See, 2 electrons, then 8 electrons, then 8 electrons, 2, 8, 8. Am I clear? So the next question number 45, the electron configuration of ground tested potassium. What did I say? Ground tested potassium. So let me take a page. we learn about potassium. See, potassium 19. We know that the atomic number of potassium is 19. So 1s2, sorry. So 1s2, 2s2, 2p6, 3s2, 3p6. Say 2, 2, 4, 4, 6, 10, 10, 10 and 2, 12, 12, 6, 18, then 4s1. That means it has 19 electron. Am I clear? So 1s2, 2s2, 2p6, 3s2, 3p6, 4s1. This is the way the potassium have this electron configuration. Am I right? So what did I just say? So the potassium 19 have 1s2, 2s2, 2p6, 3s2, 3p6, 4s1. So 19. So see the electron configuration of ground state potassium. What does mean ground state? That means this potassium is not any ion. Not any ion. That means this electron, this potassium is not excited. Ground state mean is not excited. What does mean excited? Excited mean it has it. If you look carefully, the 19, that means 1s2, 2s2, that means its outer shell is 4, right? It is the outer shell. It is the outer shell. What does mean ground state? Ground state mean if this outer shell electron stay in the atom, this is called ground state. If the outer shell, when potassium give this outer shell electron to another atom, then it will be excited. What did I just say? This is ground state. This is ground state. That means it is just neutral. Ground state mean neutral atom. But what is the opposite of ground state? Excited. What does mean excited? Say excited means this potassium is excited. That means the outer electron is donated. That means what does excited mean? Excited means the outer shell's electron is donated. Am I clear? So what will be the excited potassium? What is the electron configuration of excited potassium? 1s2. This will be removed. 2s2, 2p6, 3s2, 3p6. 4s. Will the 4s1 electron written? No, we will not write the 4s1 electron, because in the excited state the 4s1 electron will not be there, right? So the 4s will be 0. That means it will not stay. The electron is not here. It has been donated. Am I clear? Right? So that means the ground state mean neutral. That means naturally, that means just simply you have to write the electron configuration of potassium. This is mean ground state potassium. Or what does mean excited? Excited mean if the outer shell electrons is donated, that means this 4s1 electron will be missing in the excited shell. So this is the excited potassium's electron configuration, and this is the ground state or neutral potassium's electron configuration. So see which one will be the answer? 1s2, 2s2, 2p7, 3s2, 3p6. Nope. B 1s2, 2s2, 2p6, 3s2, 3p6, 4s1. This is the answer. See, ground state 1s2, 2s2, 2p6. These and these both are similar, right? These both are similar. So this is the ground state potassium. See, this has, why this is not the answer? 1s2, 2s2, 2p6, 3s2, 3p6. Again they have write 3s2. That means this is incorrect. Why incorrect? Because 3s2 is written double, right? So this is not will be the answer. So 1s2, 2s2, 2p4, here is a mistake. So this will not be the answer. So these are similar. See, this is the electron configuration of ground state potassium, and this is similar to this one. So this one is the answer. So it is not answer, it is not answer, it is not answer. So B is the correct answer. Am I right? Here is a fact that if you look carefully, after 3p in potassium, wait, in potassium, extra information. What is the extra information? In this potassium, after 3p, 3d can come or 4s can become. See, we have taken 4s after 3p, right? This 4s have come after 3p, but why not 3d? I mean, why not 3d? We could also take 3d after 3p, but we have taken 4s after 3p. Why 3d is not taken? Because this follows by n plus l rule, n plus l rules. That means this 3, remember that what is n plus l rules? N is the electron shell. 3d, that means it has 3 electron shell. This means this n has this, the value of n is 3, and 4s, that means the value of n equal 4. Clear? And L, for S, the value of L equal 0, for P, the value of L equal 1, for D, the value of L equal 2. Am I clear? So what is the value of n plus L? Here, see, for D, the value is 2, so 2, and what is the value of n plus L? Equal 3 plus 2, that means 5. But here, what is the value of n plus L? 4 plus the value of L is C. For S, the value is 0. So 0, that means 4. That means here the value of n plus L is 4, the value of n plus is 5. Always remain in mind that always keeps in mind that the n plus L, the shell which have lower number of n plus L value. What did I just say? Lower number of n plus L value will come first. Lower number of n plus L value will come first. So after 3p, why 4s is taken? Because this n plus L have lower number, and this 3d's n plus L value is higher. This is the lower value, and this is the higher value. You have to always take the lower value. So this is why 4s is taken, 3d is not taken. Am I clear? Because 4s have lower number of n plus L value, but 3d has higher number of n plus L value. So you have to take always the lower number of n plus L value. Am I right, or am I clear? So this is why we take 4s after 3p, but we don't take 3d. So hopefully I have cleared the concept, or you have already understand the topic. So the next topic is periodic table or periodic trend. So now we will read the periodic trend. Clear? So look, here is the first topic is radius and group. So let me just give me 1 minute. Here we will learn about periodic trends. At first our discussion will be on the radius and groups. So the topic is about radius and groups. So what is group? We all know about periodic table, right? A periodic table looks like that. Here this type of straight column available, right? We know that there are 18 columns. How much? 18 columns. And there are rows also available. There are row, right? This row and this column are called group. So basically the columns are called group, and there are 18 groups, and this row, I mean these rows are called, so this row are called period. Am I clear? So what I have just said, this what is group? These straight columns are called group, and this row are called period. There are 7 period. How much period available in a periodic table? There are 7 period. Am I clear? And there are 18 groups available. We all know that, right? So under the main periodic table, under the main periodic table, so what I have just said, these straight lines, I mean these are called groups. These lines or these columns are called group, and these are called, I mean these are called period. And under the main periodic table there are also 2 row available, right? This row called actinide series and this called lanthanide series. The two sub row under the main table, this row are called actinide series and lanthanide series. Am I clear? So this is all about periodic trend. Am I clear? So what are the groups? What are the period? I mean what is the group? Now you are clear. Elements in the same column act alike. That means the group elements behavior almost same. For example, we can take let me just take a page. Take a page. So if we draw, these are groups. So at first groups, if you look closely at first group, so there are 2 groups available, right? So if you look closely, they are hydrogen, lithium, then sodium, then potassium, right? So the elements of a group reacts in the same way. I mean the atom in the same groups behave alike. That means if sodium react with water and it gives sodium oxide plus H2. Same the potassium also react with water and gives potassium oxide plus hydrogen gas. So hydrogen gas. See, sodium react with water and give hydrogen gas, potassium react with water and it also give hydrogen gas. So their behaviors are same. So the elements of the same group behaves almost in the same way. Am I clear? So this is what is written. Elements in the same column act alike. That means almost same because they have the same outside valence electron. You don't have to understand that. The period. What are period? These are called period. These row are called period. Am I clear? So you have to totally ignore this slide. The slide number is 10. Ignore this slide. and also you have to read this. Am I clear? So this is most important. So see, now we will learn about radius trend. Radius trend means the size, how the size increase and how the size decrease. Radius means actually size. So now we will learn about size, how the size increase, the size can be increased, and the size of the element can be decreased. So we will learn how it increases and how it decreases. Am I clear? So see, down, bigger, more shell. That means, let me just write it. So what just have written in the slide, if you go left to right, if you go left to right, that means in a period, here in a period in a period, if you go left to right, the size decrease or size or radius decrease. Am I clear? So decrease. So from left to right, the size decrease or radius decrease, or if you go up to down, if you go up to down on a group. So in period, if you go left to right, the size or the radius decrease. If you go up to down in a group, if you go up to down in a group, the size increase. Am I clear? So if I draw here hydrogen, here lithium, sorry, let me just draw it clearly so you will understand it. See, so let me just draw atom. Okay, so hydrogen, let just assume hydrogen, lithium, sodium and potassium. See, if I go up to down, if I go up to down, the size increase. If I go, just assume after sodium, magnesium comes, then then here aluminum comes, right? Aluminum, sorry, I have just erased all of that. So so what I have just explained. So if I draw a periodic table here, so if I assume here hydrogen, lithium, sodium, potassium, so if I go up to down, the size will increase. If I go just assume after sodium, magnesium come, magnesium, here aluminum, then which element comes, silicons, right? So here if you go left to right, sodium, magnesium, aluminum, in a period, in the same period, the size decrease. That means here the aluminum is the most, here, so here the aluminum is the its size is the most smallest, right? So and this is the biggest one. Am I clear? So if you go left to right, the size decrease. If you go up to down, the size increase. So potassium is bigger than sodium, also sodium is bigger than lithium. Am I clear? So this is what just is written in the slide. So if you go down, what I have just already explained, sodium, potassium, rubidium. So if you go up to down, the size bigger. That means, and if you go right to left, I mean left to right, if you go more right, the size will be smaller. I have already explained this here. See, in this way, from sodium to aluminum, the aluminum getting smaller. When you go up to down, the size getting bigger. Am I clear? So this is what is written in this slide. Am I clear? So if you go down, the size will be increased, or atom will be more bigger. If you go left to right, the size get smaller. Am I clear? So you don't have to read this common mistake. Basis on that topic, there is a question comes always in the exam. So the question is about which element belongs to the same group in the periodic table. That means which elements belong to the same group. That means you have to find out which elements are belongs in the same group. Unfortunately, we do not have any short tricks for reading this. You have to just memorize the group elements. Am I clear? So at group 1, the elements are hydrogen, lithium, sodium, potassium. So see, you have to find out which are the same group, but unfortunately there is no short tricks to memorize them, but you have to memorize it, like at groups 1, hydrogen, lithium, sodium, potassium, then rubidium comes. At group 2, at first come beryllium, magnesium, calcium, strontium. Am I clear? At group 13, beryllium, then germanium, then indium. At group 14, at first comes carbon, carbon, then this comes, then tin. So you have to memorize you have to just look at the periodic table and memorize all the elements belongs to this group. So if you look the first group, at first group C, hydrogen, lithium, sodium, potassium. So this is the answer. These 3 elements belongs at same group, group 1. These 3 elements belong to the same group, hydrogen, lithium, sodium. Am I clear? But if you see carbon, oxygen, sulfur, these are not in the same group. This is sodium, magnesium, this comes in same period. Sodium, magnesium, aluminum, they are in the same period, not in the same group. Their period is same. What I have said, their period is same, but not the group. Then hydrogen, carbon, oxygen, these are not. So this is the answer. Am I clear? They belongs, hydrogen, lithium, sodium belongs in the same group. Am I clear? So then if, are you clear? You have to do nothing but you have to memorize the group numbers of the elements. At group number 1, these elements stay. At group 2, these elements belong. At group 13, 14, as well as you have to memorize group 15, 16, 17. Am I clear? So you have to memorize them. The next question, which of the following elements has the smallest atomic radius? The question is, which of the following elements has the smallest atomic radius? That means which is the most smallest. If you see this oxygen, this oxygen lies in period 2. this is also in period 2, this is in period 3, and this is in period 2. So you have to find out the smallest one. You have to find out the smallest one. Am I clear? So how do you figure out that which one is the most smallest? At first, oxygen here. Oxygen belongs in the oxygen, then sorry. So if you look at the periodic table, here the carbon comes first, after carbon oxygen comes, then here fluorine comes. They are in the same period, they are in the, and if you go up to down, you will found here sodium. So these all are in period 2 and the sodium is in period 3. Am I clear? So you have to find out the smallest one. So these are carbon, oxygen, fluorine in the period 2 and sodium lies in the period 3. So sodium, I have already said that, see, if you go here, sorry, see, I have already said that if you go up to down, that means if you go period 2 to period 3, you have to go down, right? And when you will go down, the elements becomes bigger. Am I clear? The elements becomes bigger. I mean the elements becomes the size increases. So if you go period 2 to period 3, if you go period 2 to period 3, the size increases, right? So the sodium is bigger than carbon, oxygen and fluorine. Am I clear? So this sodium is the biggest atom among of this atom. Am I clear? So this sodium is the biggest one because this lies down from these 3 atoms. The sodium lies in the period 3, that means you have to go down. Let me clear it. So you have to go down. If you go up to down, the size increases, right? Up to down. So that means sodium is the biggest one, but you have to find out the smallest one. So look at the carbon, oxygen and fluorine. If you look carefully at these 3 atoms, what we know that these are in the same period, and we know that in the same period, if you go left to right, the size decrease. Don't we know that? We have already said that. See, if you go left to right, the size becomes smallest. So here the fluorine lies in the most right. So here the fluorine lies in the right side. So this is the smallest. Am I clear? Why this is the smallest one? Because if you go, wait, so if you go left to right, the size increase. So the fluorine is the size decrease. So the fluorine is the smallest one. Am I clear? See, you have to find out the smallest. Between carbon, oxygen and fluorine and sodium, sodium already is the biggest one, because if you go up to down, the size increases. So sodium is the biggest one, so it will not be the answer. So among these 3 options, fluorine is the smallest. Fluorine is the smallest because we know that if we go left to right, the size decreases. So here the fluorine is the answer. Am I clear? So the fluorine is the here answer, because this is stay in the right. This is stay in the right. So this is the smallest atom, and I mean this has the smallest atomic radius, fluorine. Am I clear? So the correct order, the next question is the correct order of increasing atomic radius. You have to find out the correct order. See, at first aluminum, boron, sodium, magnesium. Here aluminum, boron, magnesium, sodium. Let me just write down the element. At first boron, then sodium, magnesium, aluminum. This is how you will, if you look at periodic table, this is how the elements are arranged, right? Boron stay in period 2 and these all are in period 3. So these are period 3 and this is period 2. So how will you arrange them in correct order? At first look, if we go up to down, period 2 to period 3, if we go up to down, the size increases. So if we go boron to sodium, I mean period 2 to period 3, the size already increased. That means boron is the smallest. That means boron is the, why the boron is the smallest? I guess I have already explained that. Because if you go period 2 to period 3, that means up to down the size increases. That means these 3 are period 3. So that means the sodium, magnesium, aluminum, these 3 atoms already bigger than boron atom, already bigger than this boron atom. Am I clear? So this is the smallest. So correct order after boron, which will come, which element will come, you have to find out. So this is the least, this is the smallest. And if you look at period 3, sodium, magnesium, aluminum, we know that if we go left to right, wait, let me clear it. So if we go left to right, see here left and right. So we know that in the same period, if we go left to right, the size decrease, right? The size decrease if we go left to right. So this is in the left, right? So this is the smallest. This is the smallest. So sodium is the biggest one, then magnesium, sodium is the biggest one because it lies in the right, left. Sorry, I have just made a mistake. This is not right, this is in the left. Sorry, this is not left, this is right. So if we go left to right, the size decrease. So this is in the right side. So this is the smallest one. So look carefully. What will the order of sodium and magnesium? Magnesium stay right of sodium. So this is bigger than sodium, and sodium lies in the left. So this is the biggest one. Am I clear? So as aluminum lies in the right side, this is the smallest one, and sodium is the biggest one. Am I clear? So this is the most smallest among all of that, but between these 3, aluminum is the smallest, sodium is the biggest. So the order will be boron is the most smallest. So smallest, I mean most smallest. Then which one is the smallest? Aluminum. Then which one comes? Magnesium. Then the which one is the biggest one? Sodium. So this is the correct order of atomic radius. Am I clear? So this is the correct order of the, see here, beryllium, aluminum, magnesium, sodium. This is the answer. Am I clear? So hopefully we have I have explained. I think you have already understand how the which one is the correct order. Am I clear? So if you go period 2, I mean boron to period 3, sodium, magnesium, aluminum, the size already increased. So boron is the smallest one, most smallest. among these three of period 3 element, sodium, magnesium, aluminum, we know that from left to right, see, we know that from left to right the size decrease, so it is in the right, so this is the smallest, this is the biggest one, so and this is the middle one. So boron is the most smallest, then aluminum is the smallest, then magnesium, then sodium. Am I clear? So this is our answer is C. So now the chemical personalities of a specific properties. So we will discuss this flame test in the next class. We will discuss this flame test in the next class, bleaching effect. So we will discuss this later. So today here is our class finished. Hope you have already understand what I have just explained. Hopefully this will help you, inshallah. So thank you for joining me to the class today.